This is Ken Johnson with another episode of Setcast. In today's tutorial, we demonstrate using Sequelize, Passport, and Express within a Node.js environment to implement authentication and access control. The first thing we want to do is create a server.js file. This is going to be the main file that is used to kick off our application. So we're going to require a bunch of libraries, Express namely. It's very important. We'll require routes, individual routes, models, the HTTP library, Passport, our Passport configuration, and a couple of other routes. If you are familiar with MVC, you can think of the routes as controllers and the methods defined within them as actions. The Passport configuration is so that we can perform authorization and access control, and the models are where our database layer logic lies. So we'll go ahead and expose the public folder so that we can store assets like style sheets and JavaScripts in there. We'll define our view folder. We'll define the port that this will run on. Leverage a couple Express libraries for body parsing and URL encoding. We'll leverage Express's cookie parser. And the session secret should never be stored in source code if this is a production application. This is used to generate a user session. We'll initialize Passport. We'll use Passport session, which essentially authenticates the session. We'll use Express's error handling if we're running this in development, and we'll create our first route. Any request that comes in for the root path or / will be handled by the index method defined within the index.js route file. Let's go ahead and create that code. So we'll go ahead and define the index method. It takes a request and response object. With the response object, we're just going to go ahead and render the login.ejs file, which is just an HTML file. So this is the login.ejs file. The important thing to note here are the parameters that are being submitted and where they're being submitted to. So there's a username parameter that's going to be submitted. There's a password parameter that will be submitted. And this will be a post request to / authenticate. Before we can authenticate a user, we must first create a database. Models in this context can be thought of as individual tables within the database. Now, in order to create those individual tables, we need to instantiate all those models and make them accessible everywhere within the code. So this file, located under the models directory named index.js, is coded up to do exactly that. In essence, we go through the entire models directory, we pull in each file, and we create this DB hash that consists of both the model name and the value, which is an actual model that you can call functions on. To reiterate, the real goal of this file is to pull in all of the files under the models directory, create the tables, make that code accessible anywhere within this application so that you can call something like user.update, you can update a user, you can change some model attributes, etc. And the last thing we have to do is go back and fix a couple mistakes, encapsulate the period on line 11 with quotes, and also make sure that we return the DB hash. We'll go ahead and move back over to the server.js file. This way we can create the database tables as soon as the application starts. Now that we've written the code to import all the model files, we will go ahead and use that DB object to call sync. This will create the tables in the database. Upon completion, we want to go ahead and handle errors if they occur. Otherwise, we will spin up an HTTP server, and let's see if it works. It's good to go so far. To address the question of how this database is being created, we leveraged Jake and created a Jake file with two functions inside of it. There is Jake dbDrop and dbInit. dbDrop deletes the database and dbInit creates the database. So we need to create a user model. We'll do this within the user.js file located under the models folder. We want to hash passwords, so we'll leverage the bcrypt-node.js library. It is important for us to code a function that both creates the table as well as defines the columns that are within this table. In this case, they are username and password. They are a data type of string. They could be string or an integer or text. Sequelize provides us with validations such as unique, which makes sure that there's a constraint on that column, that it must be unique. There's not null, which means that it can't be a null value. Not empty, which specifies that a string cannot be empty. If you would like to put a restriction on the minimum length of a password and make sure that it matches a regex, this is the place to do it. Sequelize provides those validations. In order for a successful login to occur, we have to guarantee that the password being provided by the user matches what's in the database. So we'll create this class method named validPassword, and this is going to take the password provided by the user at login, the password stored in the database, hashed of course, and perform a bcrypt hash comparison to make sure that the hashes match up and the password is valid. Our callback is named done, and we want to provide that callback with a user object if the passwords do match, but we'll provide it with false if they don't. If there's an error, we'll log it to the console. So the next thing we have to do is tell Sequelize what sort of database it's going to be working with. We'll use the dialect keyword to tell it, in this case, that we're working with a MySQL database. And an interesting aspect of Sequelize is that it does provide hooks, so you can perform a before create or after validate hook and work with the data prior to it being saved in the database. And in this case, what we want to do is every time a user is created, we want to go ahead and hash their password. So we're going to generate a salt here with a salt work factor of 12. And we want to hash the password, so we'll use bcrypt.hash and we'll provide it the user's password along with the salt that we generated previously. And we'll set the user's password to that hash and return. And lastly, we need to go ahead and define that salt work factor in the server.js file. So we'll create this constant and assign it a value of 12. And for our purposes, we want to create an account so that we can test authentication. Again, please never do this in production. This is not something that should be in your code. But because this is a tutorial, we do need to show that authentication does work. So we will create this account of admin and give it a password of admin and perform the save operation. This will occur when the server.js file is executed. And we'll go over to the console and start it up and make sure that everything's working properly. You can see that the username of admin with a hashed password has been stored in the database successfully, so our code is functioning properly. So we've got to create our Passport configuration. This way we can deal with things like session management and authorization. So we will require Passport as a library and include local strategy. These are two different NPM modules, Passport and Passport local. And we'll require the models. There are two separate functions that need to be defined for session management purposes. They're a serialized user and deserialized user. Serialized user creates the cookie and deserialized reads it. Serialized user will take a user object and embed it into the session or associate it with the session. Deserialized user will take the attribute that you've defined, in this case user.id, as a method of looking up the user in the database, and we'll return that user as an object. This allows us to call something like request.user and have the ability to work with it as well as modify that user. And then we must create an authentication function. To do this, we'll use passport.use and we'll leverage the local strategy. There will be two parameters provided, username and password. We'll look up a user by the username provided, and if they exist, we will perform a password comparison of the password they provided us, as well as the hash password that is stored in the database. Now we are going to work within the application.js file located under the routes folder. There are two things we need to accomplish. One is we need to have a way of identifying if a user is authenticated, and we also need to be able to properly destroy their session at logout. The first function we will define will be labeled isAuthenticated. This takes the request object and leverages Passport to determine if a user is authenticated. And if they are authenticated, we want to go ahead and allow the chain of code execution to continue. Otherwise, we want to render a 401 unauthorized message. The next method is destroy session. and we call request logout and request session.destroy to make sure that both Express and Passport sessions are destroyed, and then we redirect them to login. And now we need to define some routes, and we'll do that within server.js. The first route is for the user's homepage. Note that we use application.isAuthenticated as we would like to ensure that they are authenticated into the application to view this page. We then use app.post, so this will mean only post requests to /authenticate. We'll trigger the passport.authenticate function, and if the user's authentication attempt is successful, we redirect them to their homepage. Otherwise, we'll redirect them to the login page. And we'll also define a logout route, a signup route, and register route. Note that on the logout page, we do use application.destroy session. And within the user.js file located under the routes model, we need to define two functions, one's signup and one's register, per the routes we've previously defined in the server.js file. With signup, we're just going to render an HTML page. With register, we're going to take the username defined in the request and look up the user. And if they don't exist, we're going to create the user using the username and password provided by the user. Otherwise, if there's an issue, we'll redirect them back to sign up. If there is not an issue, we'll redirect them to login. And the last piece of the puzzle is just to make sure that all of this works. So we'll fire up our server and we'll browse to localhost port 3003. And we're going to log in with credentials we already know, admin and admin, and it works. We're able to log in. But we need to make sure that the home page is not accessible if you're logged out. So we're going to log out and we'll try to access it. And as expected, we get a 401 unauthorized message. Now we need to sign up a new user, make sure that the registration functionality works. So we'll sign up with a username and password of test and ensure that we can log in with this newly registered user. It does work, and this means everything's successful. I'm Ken Johnson. This is another episode of SecCast. Thank you for watching.